Good afternoon, Robert Scribbler. It is November 30th, 2018. Thank you for joining me for another climate change and clean energy video blog. So for this segment, what I am going to do is provide for you my typical Arctic sea ice, weather, and climate analysis for the region of the Arctic. But for this segment, I'm also going to provide for you an analysis of what is happening in the Arctic at the present time and what has happened in the Arctic throughout much of November has likely impacted weather across the United States in a fashion that is related to ongoing impacts linked to human-caused climate change and linked to a phenomenon called polar amplification, in which the poles tend to warm up more rapidly than the middle latitudes, in particular during hemispheric winter periods. So before I get into that, I also like to provide a couple of credits. Most of the science that is used for the basis for this analysis was developed by Dr. Jennifer Francis at Rutgers University, Dr. Michael Mann at Penn State, and a number of others who are looking at how warming at the poles interacts with upper level circulation, atmospheric circulation in the jet stream to influence weather in the middle latitudes. This is a cutting edge field of science. And because it's cutting edge, some conclusions or some statements with regards to the impacts do not yet have a high level of confidence, but the trend in the science, at least at present, is moving toward higher levels of confidence that polar amplification is influencing middle latitude weather patterns. So just a bit of context and a bit of credit to the scientists who are providing this groundbreaking new set of information related to climate change. Now, at present, so Arctic sea ice is a major factor in the changes that we are seeing in the Arctic and in the Northern Hemisphere overall. And it does relate, it has a handshake to the interaction we see with polar amplification, the more rapid warming of the pole, and the translation of changes that are being observed in the upper level atmospheric wind patterns that influence our weather. And at present, it's worth noting that over the past few weeks, the Arctic has gone through a relative cooling trend. Doesn't mean that the Arctic is cooler than normal. It's just that we've moved from ranges of around 4 to even 5 degrees Celsius above normal, maybe even higher for certain regions of the Arctic, down to overall for the Arctic as a whole ranging from about 1 to 2 degrees Celsius above normal. These are still above normal temperatures for the Arctic, but it's closer to a normal range for this time of year. So the departures that we've seen over the past couple of weeks have lessened, and as a result, Arctic sea ice coverage has tended to rebound a bit. So I'm going to go ahead and try and highlight the red line here so you can see see the trend for Arctic sea ice over the recent year. And you can see that during recent days, particularly in the middle of November, Arctic sea ice extent rebounded a bit. And over the recent recent week or so, Arctic temperatures have tended to increase a bit, so the rate of refreeze for the Arctic has again tamped down over the past 7 days or so. Now, at present, Arctic sea ice extent is in the range of around, looks like about 7th lowest on record for this time of year. We are still trending about 1.5 million square kilometers below the 1980s average, about 1 million square kilometers below the 1990s average, about 300,000 square kilometers below the 2000s average, and slightly above the 2010s average. But overall, the present season of sea ice is a reflection of the longer-term trend of Arctic sea ice loss that we have seen as both the globe and as the pole has heated up, and as the pole has heated up more rapidly than the lower latitudes in the Northern Hemisphere. So despite the fact that we've seen a bit of a rebound in sea ice, it's not an indication at all that global warming stopped. In fact, we're just going through variable phases as we tend to see with weather in the Arctic, but the overall trend is one of warming still. Now, looking at Arctic sea ice extent, according to the University of Bremen concentration map, we still see large areas of open water in certain regions of the Arctic, in particular regions of the Arctic associated with the Pacific Ocean and the Atlantic Ocean. And this has become a trend over recent years in which we have seen more energy transfer moving into the Arctic over the ocean zones during fall, winter, and spring. And I'd just like to point out the open areas of water here, north of the Bering Sea and into the Chukchi Sea, and here north of Svalbard, as we have seen warm air influxes continue and start to ramp up a bit through these zones. Now, according to GFS, we're expected to see some warm air incursions over both of these zones over the coming days, and I'm going to talk about that a little bit more. At present, the Arctic has cooled off a bit relative to recent much warmer than normal temperatures. We're still warmer than normal, and it does appear that the Arctic is preparing to go through another phase of warm air invasion in which temperatures spike a bit to rather warmer than normal conditions. I'm going to talk about that a little bit later. Now, looking at the Arctic sea ice concentration map, we do see that these zones associated with both the Pacific Ocean and the Barents Sea near the Atlantic are seeing considerably reduced sea ice extents versus the median ice edge from 1981 to 2010. It's worth noting that this ice edge from 1981 to 2010 that is provided by the National Snow and Ice Data Center, even though it's a median ice edge, it's also reflective of a period of time in which sea ice was declining. So the ice edge, say for example, the median ice edge for the 1980s would be much further south in all of these regions. So this 1981 through 2010 period captures a period of sea ice losses. So this ice edge is not really indicative of what would have been normal for, say, the 20th century. It's more indicative of a median for a period of loss. Even though it is over a 30-year climatological period, it's still capturing a good bit, in fact, of the warming that we have seen at the pole. So the typical ice edge for the 20th century would be rather further south. But even so, we see much reduced ice extent in these two ocean-associated regions, and this is also in association with the warm air influxes that we have tended to see coming in through the ocean zones during Northern Hemisphere fall and running toward Northern Hemisphere winter. Now, looking at the Danish Meteorological Institute's mean temperature anomaly graph for the regions of the high Arctic, and these are regions near the pole in the 80-degree north latitude line and above, we see that most of Northern Hemisphere fall, so this period of time here in the graph, has seen much warmer than normal temperatures, even though we've seen a rather steep drop-off in Arctic temperatures closer to the baseline during early to mid-November, with a bit of a rebound over the recent week. Now, it's worth, just to provide you guys with some context, it can be a little bit hard to understand this particular graph. So the green line represents the daily mean temperatures in the near polar region from 1958 to 2018. So this is the green line bell curve of temperatures that we would typically see in the Arctic during this period of time. It is worth noting that this period of time also captures a period of warming. So if you were to take a 20th century baseline, it would probably tend to be, almost certainly tend to be below this green line here. But what we have seen during fall of 2018 is much warmer than normal temperatures overall for the high region of the Arctic near the pole. And this is also captured in the measure of freezing degree days provided also by DMI. And as we can see freezing degree days are the second lowest on record at present, in the present record, for the period of 2018 and 2019. Now, freezing degree days are basically an aggregate measure of temperature averaged over days and above or below a baseline of freezing. So the closer you get to zero, so the less freezing degree days you have, the closer you are to Arctic thaw. And so at present, we are seeing a very warm Arctic for fall, despite the fact that we are running a bit above the record warm year. I'm sorry, running a bit below the record warm year of 2016 and 2017, but we're still showing warmer temperatures than the 2018 through 2019 period overall, with the aggregate mean daily anomaly for the 80-degree north latitude line and above. So this is the near polar region, in the range of about 5.29 degrees Celsius above average. So much, much warmer than typical temperatures overall for the fall for the high northern regions, for the regions closest to the pole. Now, looking at the infrared satellite imagery showing sea ice, we do see that sea ice extent is starting to take over large sections of the Arctic, but we do still see in the satellite shot large areas of open water, as we mentioned before, in the Chukchi Sea, rather thin ice in the edge zones running in through the Kara and Laptev seas, and rather reduced, much reduced sea ice, polarboard reduced sea ice north of Svalbard. It is worth mentioning that this line here north of Svalbard has maintained about the same since summer, so that we haven't really seen much growth in sea ice in the north of Svalbard zone, and that's really indicative of the energy transfer that we have seen continuing through the Barents, as well as the energy transfer that we have seen running up through the Bering Sea and the Chukchi Sea. Also, just like to point out that sea ice cracks are quite extensive into the Beaufort Seas, seeing the effects of both winds and the rotation of the Beaufort Gyre on the much thinner than typical sea ice that we would tend to see at this time of year. So just the cracks are just another indication of how much more frail the Arctic sea ice has become over recent years, as the decadal trend of loss just really starts to dig in. Now, looking at temperature anomalies for the Arctic, at present, for the Arctic as a whole, temperatures are ranging about 1.4 degrees Celsius above baseline averages from the 1979 to 2000 period, which is already, yes, a warmer than normal period. It's also worth noting that no major climate zones in the present GFS model indicate cooler than normal temperatures, and for the world, temperatures are running about 0.6 degrees Celsius above the 1979 to 2000 baseline, which is rather warmer than normal, about 1.1, in the range of about 1.1 degrees Celsius if you compare it to 1880s baselines, maybe as high as about 1.2 degrees Celsius if you compare it to 1880s baselines for the day. And again, no major climate zone showing below normal temperatures, despite the fact that we do get some cool pools here in some of the middle latitude regions, or regions south of the Arctic, as you get cold air flushed out of the Arctic as the Arctic has tended to warm. Now, it is worth noting, as I said before, that the Arctic has cooled relative to very extreme warm temperatures over recent weeks and months, and this has enabled a flattening out of the jet stream. And I'm going to talk about this a bit. Just looking at the jet stream on November 11th, we see a very wavy jet stream pattern, and this very wavy jet stream pattern occurred in association with much warmer than normal temperatures along the U.S. West Coast, much drier than normal conditions, where we saw this very strong ridge pattern over sections of the U.S. West that helped to enhance the fire risk and fan the very severe fires that we saw, in particular the campfire and the fires that destroyed a number of, destroyed Paradise, California, and a number of other small communities in the region of Northern California. And this high amplitude jet stream wave occurred during a period when the Arctic, as I mentioned before, was much warmer than normal, ranging about, in the higher latitudes, ranging about 6, 7, maybe 8 degrees Celsius above normal at some points during this time, in which we saw a strong ridge pattern which tended to block moisture flowing into the western United States at a time when rainy season would typically develop. Now, as the Arctic had cooled somewhat relative to much, much warmer than normal conditions, we tended to see the jet stream start to flatten out. Now, I'm going to go ahead and advance this model and show you what happened to the jet stream. So through mid-November, through the November 15th timeframe, 16th timeframe, we still tended to see ridge patterns across the U.S. West, with the storm track still interrupted by ridging across the U.S. West. But as we got into the third week of November, we began to see the ridge pattern start to soften a bit, and the storms track, which is indicated by this flat, fast jet stream across the Pacific Ocean, start to enforce. And this occurred even as the Arctic was cooling down to closer to normal conditions. So in this time period here, when the Arctic was cooling down. So we did see the storm track strengthen, and we saw a number of storms running in through the Pacific Northwest. And this is indicated in the precipitation maps provided by the National Weather Service and weather.gov, showing that we have seen over the past week some rather significant rainfalls in regions of California that were hit so hard by the wildfires as the Arctic cooled off and as the storm track flattened, and there was, there's been a bit of flooding as a result, because the denuded hilltops and have tended to soak up less moisture, and this tends to happen as vegetation is destroyed by wildfires, and risks of things like landslides have increased with these high precipitation totals, even as the Arctic flipped back to this warmer, more normal regime of closer to normal temperatures. Now, it is worth noting that human-caused climate change does amp up the hydrological cycle, and so you can get these hard swings between very dry conditions to very wet conditions, which has also aided in intensifying the extremes that we are seeing in California, as well as, in particular, this extreme swing from very dry, fire-based conditions to very wet conditions. Now, it is worth noting that the rain across the U.S. West has tamped down wildfire activity, with the Camp Fire now 100% contained, and other fires across the West nearing containment as well. So the fire regime across the West has been tamped down. But just to give you some perspective, that even though the seasonal influx of wet season has occurred, albeit late, California itself is still undergoing drought conditions. And so what we are seeing now, despite heavy rain, is a continuation of drought conditions for California. And we are now entering the 363rd week of continuous drought for California, which has been enhanced by a tendency of ridge patterns across the U.S. West and a tendency for warmer and drier conditions across the U.S. West. And it's worth noting that California is not the only region affected by drought. Much of the U.S. West is affected by drought, and that California is also not the only region that is affected by wildfires, in association with this warmer and drier than normal pattern, that we have seen an increase in large wildfire frequency across much of the West. So this is a drought monitor map for November 20th, and then the most recent drought monitor map released this Thursday shows very little change in drought conditions despite the influx of moisture. And this is just indicative that despite the fact that we've seen instances of heavy rain over a few days, that the overall longer-term trend for California is still one of, and the U.S. West is still one of drought. Now, looking at the future, and I want to look at a couple of maps indicating what is expected to occur over the coming weeks. And the first map is, well, actually over the coming 7 to 10 days. And the first map I just like to look at is the expected precipitation map. And it's worth noting that we see, at least in the prediction, in the NOAA QPF, WPC QPF prediction models, showing an abatement of precipitation across the U.S. West. It's still a wet pattern, but it's not as wet as it was over the past week. And so sections of the U.S. West are expecting between 1 and maybe 1.75, possibly as much as 2 inches of rain over the next 7 days, which isn't as much as we've seen over the past week, in some cases with regions experiencing between 6 and 8 inches of rainfall, possibly a bit more in some rainfall hotspots. And what's happening? So, well, actually, before I get into answering the question of what's happening in the Arctic and what may be influencing this weather pattern, I'd also like to point out that over the U.S. East, precipitation totals are expected to rise. And this is as the trough zone for the U.S. East is expecting to reassert and bring a stormier pattern along over the next coming days, even as the wet season pattern tends to moderate in the U.S. West. So what's happening? I'm going to go ahead and play some models for you. This is a global forecast system model, and what it's showing is that the Arctic is expected to warm up over the coming days, increasing from about a 1.4 degrees Celsius temperature anomaly now to closer to 2 degrees Celsius temperature anomaly as we get into Sunday. And then as we get into next week, I want you to look at these two zones that I indicated earlier, the one in the Pacific and the one in the Atlantic, where we see these bulges of warmer than normal temperatures starting to ride into the Arctic. And by Tuesday and Wednesday, the Arctic spikes up to around a 2.8 to 3 degrees Celsius anomaly for the entire Arctic and pushes into the mid 3 degrees Celsius anomaly range by late week. And I'm going to go ahead and slow this down so that we can, or just stop this for a second so that we can get a snapshot of what's occurring. So we see much warmer than normal temperatures here invading the Arctic, pushing the Arctic in the range of 3.5 degrees Celsius above normal, which is about 2 degrees Celsius overall warmer than what we have seen over the past couple of weeks. And as a result, we are tending to see a reassertion of ridge patterns in the latter period for the U.S. West. And you can see this in the form, in the temperature maps, in the form of warmer than normal temperatures running in through Alaska and British Columbia and the Pacific Northwest. And I'm going to go ahead and just look at the jet stream map and also show you what is predicted to happen with the jet stream over the U.S. West, with at present a flat, fast jet stream running across the Pacific. But as we get into the latter period, I'm going to go ahead and just jump ahead so we can see how the jet stream tends to get wavier. See this break? So the jet stream tries to run flat and fast all the way to the Pacific coast, but it gets broken up, and we see a ridge pattern starting to emerge through Alaska by the middle of next week, and reasserting with a second wave through the latter portion of next week with almost like an omega block kind of pattern starting to emerge again for the U.S. West. So that kind of pattern would tend to reduce the frequency of and intensity of storm events, which is presently predicted in the NOAA QPF models. Not to say that the West Coast won't see rain over the period, but that rainfall intensity would tend to drop off. And this is the period when the West Coast gets its typical higher than normal, typical high moisture levels, which reinvigorate snowpacks, which reinvigorate aquifers, and which provide some potential for tamping down the longer term trend of drought. So an interruption in the moisture flow is not really good news, but it's also another indicator that what happens in the Arctic, when the Arctic warms up, it doesn't really stay in the Arctic. And we tend to see more of a ridge pattern across the US West and more of a trough pattern across the US East, which tends to bring cooler temperatures across the US East and stormier conditions, even as the Arctic is much warmer than normal. Now, looking at the latter portion of this forecast, I would also still like to note that there are no major climate zones around the world showing cooler than normal temperatures, despite the fact that we do see some cool pools here in these trough zones. But overall, the signature is one of warming and warmer than normal temperatures. So just a large-scale overview of some of the major synoptic patterns that appear to be influenced now by warmer than normal temperatures and variance between closer to normal temperatures and then spikes back up to much warmer than normal temperatures across the Arctic that have an impact on middle latitude weather, or that appear, at the very least according to these observations, to be having an impact on middle latitude weather in a way that is not typical of the usual 20th century weather patterns we have tended to see. And again, I just like to provide a reference for Dr. Michael Mann and Dr. Jennifer Francis, who were the scientific messengers to point out that some of these changes were ongoing, not just in winter, but also in Northern Hemisphere summer. Now, before I conclude, I would just also like to point out that at present we are seeing much warmer than normal sea surface temperatures across most of the Pacific Ocean, and that the Pacific Ocean overall, in a very uniform fashion in the Northern Hemisphere, is showing warmer than normal ocean conditions. And this is a rather unusual picture. We have tended to see much warmer than normal conditions for the Northern Pacific Ocean overall, but this particular pattern, where we see from east to west and west to east and north to south, warmer to much warmer than normal conditions, with only very small cool pool here in the Central Pacific, it is not usual at all. And so just a measure of concern as we get into Northern Hemisphere winter. If these conditions continue, it is likely to enhance energy transfer and heat transfer into the Arctic through the Pacific region. And I'd also like to point out that the Barents Sea is also rather warmer than normal, particularly near Svalbard, where we do see a hot spot in the Earth Null School Monitor. And it's worth noting that the Earth Null School Monitor shows temperature anomalies based on its own baseline, and that the NOAA monitor itself may use a different baseline that generates a more moderate departure. But overall, these regions are seeing warmer to much warmer than normal water temperatures, particularly west of Svalbard, where in the Earth Null School Monitor, we see a 10.9 degrees Celsius departure. And we have tended to see this warm pool here near Svalbard be rather consistent. We also have another warm pool off Svalbard to the south in the Barents Sea, with the Barents Sea overall warmer than normal, which will also tend to aid in warm air influxes through the Barents Sea. And during recent years, we've seen warm air influxes that push temperatures above freezing or close to freezing near the North Pole during Northern Hemisphere winter. And this is something that we should probably continue to monitor to see if this occurs again during the winter of 2018 and 2019. Well, one last map I'd just like to look at and just show you that there is consistency between the Earth Null School map and the NOAA ESRL maps. And this is a daily sea surface temperature anomaly map provided by NOAA ESRL. And we do see that that widespread warmer than normal condition for the Pacific Ocean and running into the Chukchi Sea, as well as warmer than normal conditions for the Barents Sea. So consistency in the anomaly map showing these warmer to much warmer than normal ocean zones, and areas that we need to look at for energy transfer into the Arctic as we get closer and closer to Northern Hemisphere winter. So a very detailed analysis on both the Arctic sea ice and how Arctic warming and polar amplification appear to be impacting Northern Hemisphere, in particular North American weather during the fall and running into the winter of 2018 and 2019. Before I finish, I would just like to note one final feature that is likely to influence Northern Hemisphere weather during the winter and into spring of 2018, 2019. And it does appear that we are starting to get into an El Nino type condition for the Pacific Ocean. And El Ninos in the Pacific do tend to, or at least have an influence on the jet stream, in that in the early stages and middle stages of El Nino, the storm track tends to be intensified a bit. Now, this El Nino is not as strong as the 2016 El Nino, or at least it's not looking like it's going to be as strong as the 2016 El Nino, so we're not as likely to see as strong influences from this El Nino as we did from the last one, but it is something that we should keep in mind. It's also worth noting that during the end phase of an El Nino event, you tend to see a lot more heat transfer into the polar zone. So something to keep an eye on as well as it interacts with the overall human-forced warming of the polar zone and the interactions that we appear to be seeing with upper-level atmospheric circulation patterns. So just a very broad analysis, and again, before I go, just like to note that at present, Arctic sea ice extents, according to the JAXA monitor, are in the range of about 7th lowest on record for the day. And for the coming 7 to 10 days, we expect the Arctic to warm up yet again, which would tend to slow down rates of refreeze for this time of year. So thank you for joining me, and I'll be chatting with you soon.